Hey everyone, so this video is going to cover one of the most common and easiest ways that you can escalate domain privileges from a low-level user all the way up to domain or enterprise admin, and that's through NTLM relay against an HTTP web enrollment on a certificate authority. I read about this in a really good white paper called Abusing Active Directory Certificate Services by Will Schroeder and Lee Christensen. They label it as an ESC8 attack, and the video will cover the manual way to go about enumerating and finding the certificate authorities, and then manually going through the steps on abusing this, along with the automated way that I'll call it, which is using Ceritpy, and it's just a few commands, but feel free to skip around, and at the end I'll show some defenses or recommendations on how to remediate this. ADCS, or Active Directory Certificate Services, is just a role inside the environment that allows users or computers to grab certificates. It provides a way of authentication, and you use certificate for different things. So for example, whenever I was setting up LDAP-S in my domain, I needed a certificate to pair with LDAP. So I created a certificate, and then I used that to create LDAP-S. Similar thing with HTTP. To make it secure, you need a certificate for that. So just a high level of what this attack is going to do is some of these certificate authorities have web enrollment enabled over HTTP. And what that typically does is it allows a domain object to grab a certificate through the HTTP site. The real vulnerability comes whenever it allows NTLM authentication, because with that brings a possibility of relaying NTLM authentication onto the HTTP web enrollment site. And once we go through the steps, you'll see more of what I mean. But the first thing that we need to do, and we're going to go over the manual part first, is that we need to find out what are the certificate authorities. So my favorite thing to use is LDAP search. It's a common tool used by administrators. I used to use it whenever I was a sysadmin. So I really liked the tool LDAP search, and it's also what the automated tool Ceritpy, which I'll go into later, uses to enumerate the domain. And since it uses LDAP and you're enumerating the domain, you do need some credentials. It doesn't have to have any privileges. Low-level user domain credentials are perfectly fine, which is what we'll be using. So to bring out the LDAP search command, and the -X is going to be for a simple search. The -B is going to be for a base search, because we're going to be searching through all the objects. And this is the specific one that we're going to be looking for, which is going to be enrollment services, public key services configuration, followed by the name of the domain, which in this case is middle-earth.local. If you have a different one, you would fill this out. So if it's company.com, right here, it would be company. Right here would be .com. If, for example, it was dev.company.com, you would add another DC equals, put it right here in the front. And the next thing we're going to need to do is pass the LDAP server or machine that we're going to be performing the search against. In this case, this is the domain controller. You can enumerate the domain and just look for port 386 that's open and try that. But you could just use the domain controller, which is perfectly fine. The -D is to provide a user authentication that you're going to be using. So in this scenario, we have compromised the account Golem, and we're going to be using that to authenticate for LDAP search to enumerate the domain. And then followed by providing this object class of PKI enrollment services. So PKI enrollment services is an object class that's attached to all the certificate authorities, and all the certificate authorities are placed in this container as well. So that's why we're using these two to find the certificate authorities. And if you want, you can output it to a file. So I like to use T, which is TEE. We could just name the file whatever you like. So I'll just do it CA enum. You enter the password of the user that you're using, in this case Golem, and it outputted the information. In my environment, I only have one certificate authority, so I'm just going to go through the results, but feel free to just use grep, and I'll use a command at the end just to kind of show you how to use grep to find stuff. But to scroll up at the command, we entered the password, and it only has one entry like I mentioned. So if we scroll down to DNS hostname, which is this right here, that's going to be the actual host name of the server. Now, it's going to be different from the name of the certificate authority, which is right over here. Whenever you're putting ADCS on a server, you're going to create certificate authority name for that server. It's going to be different than the actual host name. You could kind of compare it to having a server and making it a domain controller. So say you have a server named server1 and you're going to create a domain called middleearth.local. Active Directory on that server is called middleearth.com, but the server hostname is called server1. So it's kind of similar in this way, where the actual hostname is going to be under DNS hostname, which in this case is isengard.middleearth.com, and the name of the certificate authority service is going to be middleearth-isengard-ca. And I try to emphasize this because whenever you're dealing with Ceritpy or you're attacking ADCS, you're going to need to distinguish these two and provide them in different fields. And once we go to the automated section, you'll see more of what I mean. But right here, the main thing we're going to look at is the DNS hostname. It also provides the certificate templates that are found on that certificate authority. Now, sometimes in live environments, you'll see a string of characters or the SID, and those have to be converted. Ceritpy does convert most of them, which is really good. And in this case, there's nothing too crazy. So I believe I only have like 2 custom ones, which are the Find Me one and the LDAP-S. These other ones are built in whenever you first create your ADCS environment. It automatically puts these in there. So you'll see one for user, one for machine. And this one right here for domain controller, you'll see in the next few steps that we're going to be abusing. But this is the one that's going to be available for domain controllers to use and to grab a certificate. And just to quickly go over what a template is, it's kind of just a blueprint on a certificate. I know it's pretty high level, but there's so much more to go into, and there's not enough time in this video. If you do want me to go more into ADCS, feel free to leave a comment below, and if there's enough attention, then I'll make a video going more in depth on ADCS in general. And just to show you what it would be like to use grep, you could just grep-i DNS hostname, and then the name of the file. If you want to look at the templates, of course, just change this to the templates. And you can mess around with grep if you have a lot, just to kind of quickly see what are all the CAs in the environment. So now that we know that there's CA in there and we have the hostname, let's go see if they have HTTP Web Enrollment enabled. And this is the same way that Ceritpy uses to put the little flag that it is enabled. Again, in the automated section, I'll show you what that means. But we'll just do a curl command, and we'll do -i to get the headers. And then provide it the HTTP endpoint. So make sure to put HTTP, not HTTPS, and then the DNS hostname of the server. This right here is a location on where the certificates are located at. So you can provide it that. If you want, you could remove the cert FNS ASP and just leave it like that if you want. And press enter, and it's going to make the request. This right here is totally fine, because you need an authentication in order to actually gain access to this endpoint. So that's why it says 401 unauthorized. If it said something else, such as like 404 not found, or sometimes the forbidden one doesn't work as well. So those 2 other errors most likely mean it's not enabled, but you still go ahead and try. So again, the 401 unauthorized is perfectly normal. The main thing that we're looking at right here is this authentication. So if it has the authentication of NTLM, then that gives high confidence that this will work. Now Ceritpy, all it checks is this right here, which is it just checks if it gets a result that that the site is live. It does not check that it has NTLM authentication. So that's another good way to check on the manual way if you're having issues with Ceritpy, is to go through these steps and then see where you're getting the exact error, and it'll give you a better idea of what exactly is going on. So now that we know the certificate authority hostname, and we know that there's an HTTP endpoint enabled that allows NTLM authentication, now we can do some trickery or coercion to trick a machine, in this case would be the domain controller, to authenticate to this HTTP Web Enrollment endpoint. And it will essentially grab a certificate for that domain controller. And certificate, like I mentioned earlier, is a way to show authentication, to show who you are. And once we grab that certificate of the domain controller, we're going to use that to grab a ticket grinding ticket, or TGT, from the domain. Now, once we have the TGT, we can use that to do Kerberos authentication and eventually grab hashes from the domain controller of any user that you want. So I know that's quite a bit, but again, we're going to walk through these manually. And another good thing about walking through this manually rather than just running the Ceritpy command is you'll actually get to see all these steps happening. Once we go to the automated, you'll see how quick it is, and you'll kind of get lost on what exactly is going on. So let's set up NTLM Relay X to have the relay ready, relay the NTLM credentials. So we're going to be using npacket NTLM Relay X, debug just to see any errors that are going on, SMB2 support, and then the target, which is going to be that same endpoint that we used. Make sure to have cert fnsh.asp, and then we're going to put the template that we're trying to grab, which in this case is going to be domain controller, and then pass the ADCS flag for NTLM Relay X. Quick correction, so it's -T, not -target, and then it's 2 dashes for ADCS. I got my syntax wrong, but hey, that happens. So click launch that off, and you'll set up the relay being ready. Now we're going to be using a coercion attack to trick the domain controller to authenticate to our relay that's going on over in the other tab. Now my favorite one to use is DFSCoerce, and I'll link the GitHub to DFSCoerce, and pretty much what it is it abuses or tricks the domain controller to authenticate, and it has some details right here on the protocol that it uses to do that. It is a variation of PetTesting, which came out maybe like 1 or 2 years ago. So PetTesting came out. That one I don't believe needed credentials, and once a patch for that was created, later on some researchers found that you could abuse this protocol and created DFSCoerce. So we'll be using that, and we do need credentials for it. So the syntax right here is as follows. Just call the script -u. You're going to pass the credentials of the user and the password. I like to put it in single quotes so it captures any of the special characters like the exclamation mark. This one's going to be the IP of your machine. So if we go to ifconfig, it's going to be your machine's IP address. And then it's going to be the IP address of the domain controller that you're going to be tricking or coercing. So we can launch that off. Now the errors, you'll be getting some errors, and that's totally fine because it's creating a fake SMB share. And so you're going to get errors like the share doesn't exist or certain stuff like that, because I mean it's not a real share, it's a fake one that you're using to trick it. So the main thing is this right here. The successfully bound is kind of what you're looking for right here. Now if we go back to the NTLM relay, we'll see that it did grab a certificate, and it's for the machine account, and you could tell machine accounts because it ends in a $sign compared to normal domain users. So whenever you see $sign at the end, that means it's a machine account. Just copy and paste, or just copy the text right here, and it is in base 64, and just input that into a file. My favorite editor is Vim, so I'll just save it Mountain Doom cert, because Mountain Doom is the name of the server. Lowercase I to insert, and then you could just paste it right there. Escape :WQ, all lowercase, and if we look at the file, we can see that it's there. So now we have the certificate in base 64, and we can use that to grab a TGT or ticket grinding ticket that we'll later use for Kerberos authentication. All right, so now that we have the base 64 string of the certificate, what we're going to do with that is use that to perform a pass a certificate attack and grab the TGT or ticket grinding ticket for that machine account, which we'll later use for Kerberos authentication. And what we're going to be using to get the TGT from the certificates is one of the tools from PKINITools that's created by Dirk Jan, and I'll link it in the description below. And specifically, we'll be using the getTGT pkinit.py script. So if we run the help command of that tool, we'll see that it requests a TGT using Kerberos PKINIT. So PKINIT is a protocol within Kerberos, and there's different inputs that it allows. The one we'll be using is the base 64, since we have that string that we got from relaying. So we're ready to set up our command, which would be as follows. So call the tool, we're going to pass the flag of pfx base64 since we have the base64 string, and we're going to output that file that we saved it to into the command. So we're going to cat that file, and the $sign in the parentheses means it uses the output and puts it into the command, followed by the owner of that certificate. So you declare the domain name followed by the machine of the name of the machine. So that's why we have the $sign at the end, and then the file that we're going to save it into. Since it's going to be a C cache, we're going to append the C cache at the end. It's not needed, but just so we know what file that's referring to. And then I like to do the DCIP. Sometimes you might get errors if you don't declare the DCIP, so I like to include that as well. We execute it. It shows us that it's getting the certificate, it requests it, and then it saves it into a file. And this string right here, we're going to save it because we're going to use it in a later command. So save that key. Now what we're going to do next is save this C cache file that it just created into our Kerberos 5 cache. And so to do that, we're going to export it into the variable krb5cc name, which is the Kerberos 5 cache, and we're going to give it the file that we just got of the C cache. Now that it's saved in there, we can perform commands using that Kerberos authentication. And next, we're going to use impacker secrets dump to obtain an NTLM hash of any user in the domain. In this case, we're going to target a domain admin, which is Gandalf. So we're going to call the secrets dump and do -k for Kerberos authentication to use this authentication or this cache that we just obtained. And then this may not be required, but I like to declare it anyways just to reduce any errors that might come up. So we're going to call out the domain name, the name of the user that we're going to be using, which is the machine account of the domain controller, and then the machine that we're targeting, which also happens to be the domain controller. So mountdoom.middleearth.local, debug just in case there's any issues to display debug output. And I like to just declare one user. If you don't add this flag, it'll dump all the NTLM hashes. So if you're in a real environment where there's thousands of users, it'll dump all of that into a ntdit file, which is stored on the domain controller, so you don't want that. And then after that, you declare the DCIP. Press enter. Right here it'll ask for a password, but we're using Kerberos authentication, so just press enter, and then it'll use the Kerberos authentication. So if we look right here, it says using Kerberos authentication of that C cache file, and then right over here is the NTLM hash. So we'll save this, and with that hash we could put that into any pass the hash tool that you like. I like crackmap_exec, so I'll use that one. Call out the tool for crackmap_exec. We're going to be using SMB. The IP that we're going to target, which is going to be the domain controller, because we're trying to show that we have domain admin privileges. So by showing you have administrative access on a domain controller would be good enough. After that, we're going to call out the user and then the hash, capital H, and then we have this colon right in front of the hash, and then I'm just going to list the shares. So you could put any command that you fancy right there. So press enter, and then we'll see that it shows pwned. Pwned means that you have administrative access on a machine, and the way that it declares that is by having the access on the admin share. So if you had admin share access on a machine, then that means you have administrative access on that machine. So this shows that we have domain admin access on that domain. Now the next thing I want to show, if we take a step back, whenever we obtained the key from getting the TGT cache, is we're going to just get the hash from the machine account. So we're going to skip the secrets dump and this one, and we're going to go back to right whenever we get the mountdoom.ccache file. So we got the mountdoom.ccache file, and we're going to export it into our Kerberos 5 cache. And then after that, we're going to use one of the other tools that PKINITools provides, which is get_nt_hash.py. And what that does is it gets the nt hash of the machine account. Now this creator of Dirk Jan also has a really good blog post, which is also linked in his GitHub, and I'll put on the description below. is he has this blog post, and it does a really good job of describing the attack as well. I came across this whenever I was looking for a more manual way, so I came across his tools, and then I saw he had this article which does a really great job of explaining how this happens. And whenever we go into the automated way with Ceritpy, you'll also see an NT hash be extracted from the machine account. So this does a good job explaining on how that even happens. So if we look at the blog post by Dirk Jan, he has this section obtaining the NT hash of the computer account, and he also links the white paper that I'll put below for abusing Active Directory certificate services by Will Schroeder and Lee Christensen, who I mentioned at the beginning of the video, so I'll link that also below. But he goes into the reason, which is when certificate authentication is used and a TGT is obtained, there has to be some way for the account performing the authentication to fall back into NTLM authentication if Kerberos is not supported. For that reason, the KDC will supply the NT hash of the account in the PAC that is used for the TGT. So because of this fallback of possibly needing NTLM authentication if Kerberos is not supported, the NT hash is able to be extracted from this. So we have the TGT, and we put it into our cache of Kerberos 5. So now we can use that get NT hash. So we're going to call that get NT hash.py. We're going to pass the user that the TGT is from. So it's going to be the domain and then / the machine account name. And it has a $sign, so we need to add the \, that way it includes it and it doesn't think that it's the bash $sign, which declares variables. So we need to add this / as well. I believe you could also put these in parentheses and then not need the /, but this way it works just as fine. And then we're going to declare the key that I mentioned earlier whenever we obtain the TGT. So we're going to use that same key, and then we're going to declare the DC IP address. Now this isn't always needed, but you may encounter issues if you don't declare this, some weird issues. So just to save some time, I just like to declare the DC IP as well. We press enter, and then now we have the NT hash of that machine account. So now we can check out to see if that machine account hash actually works with any pass the hash tool that you like. In this case, again, I'll use crackmap_exec. So crackmap_exec, we're using the SMB protocol. It's going to be against the same machine that Mountain Doom is. So the IP of that one. You can also put the host name if you like. The user, which is going to be Mountain Doom with the $sign at the end. Capital H, and then the NT hash with the colon right in front of it. And then whatever command you like to use. I just like shares. Press enter, and you show that with the + that it is a valid authentication. So with this, you could also do secrets dump and then pass the hash of this one. All right, so now what we're going to look at is the automated way to do that, which is just using Ceritpy for all the commands, and you'll see that it's a lot faster. But again, I like to show you the manual way, and I just say manual because it's more of a step-by-step than using the Ceritpy, and you'll see what I mean. But before we use LDAP search to find the certificate authorities, in this case we'll use Ceritpy's find command, followed by the user that we obtained, the credentials of those, and then DCIP that it's going to be doing the LDAP searches against. You'll get these errors because it's trying different methods to obtain the information, and then it'll output these into 2 files, or 3 I should say, because it also has the zip of them, which you can use for Bloodhound. The one we'll be looking at is this text file. So you could just cat out the .txt file if you like, or you can use the grep command and see if there's any vulnerabilities with the -i for case insensitive search of the pattern vuln. And then we're going to get one line after the match followed by the file name. Press enter, we can see that we have that ESC8 web enrollment enabled vulnerability. We also have 2 ESC1 vulnerabilities that I'll make a video right after this, so you can check that out and I'll link it below as well. And so the one we're focusing on is the ESC8 one. So now we can just cat out that file. And the CAs are right at the top. These bottom ones are all the templates that it finds, and templates are just a blueprint of the certificates. And in my ESC1 video, I'll go more details on templates and show you some more cool stuff on there, so make sure to check that one out. And again, if we scroll all the way top, and if the environment has more than one certificate authorities, it'll list multiple ones right here, and then after that it goes into the certificate templates. So it shows ESC8 Web Enrollment enabled, and right here is how it declares that it's ESC8, and it shows that it's enabled. So the way that Ceritpy flags things as vulnerable, it has a list of each ESC, so ESC1, ESC2, and then it has set checks that it does. So for ESC8, it checks if web enrollment is enabled. For ESC1, it has other fields that it checks, and if those are set a certain way, then it'll label it as ESC1. So like I mentioned before, at the very beginning, web enrollment is declared enabled by performing a check on that HTTP site /CRSV, and if that site is up, it'll automatically mark this as enabled. But I have seen in real life scenarios that it will have this as enabled, it will flag this as ESC8, but the exploit won't work because the site does not allow NTLM authentication. So that command I showed at the very beginning where you do the curl-I and it says NTLM authentication is set. Well, Ceritpy doesn't do that. It just checks to see if the site is live, if the HTTP site is just up at all. So that is one case where going the manual way will help out, but that's just a tip. But in this case, it is vulnerable, so we'll be using the full automated exploit and using the Ceritpy command. So in the manual way, we use impact and NTLM relay X, and we had to have a lot of flags. But on this Ceritpy one, it's a lot more simple, because all it's going to be doing is just relaying for ADCS, so you don't have to customize the tool to perform an ADCS relay like you do with NTLM relay X. So Ceritpy and then the option relay. You could do -H to get more information, but we already know what we need to know. So we'll be using the template domain controller. Whenever you set up ADCS, you automatically get a certain templates already pre-configured. And one of them is domain controller. Now there's different templates. Whenever I go into the remediation section of this video, you'll kind of see more of what I mean whenever we look at the certificate authority itself. But there's certain templates. There's one for user, there's one for computer, and there's one for domain controller. Now the difference between domain controller template and the computer template is that a domain controller cannot get a computer certificate. There has to be a special one called the domain controller. So that's why we're specifically saying domain controller template and not the computer template. And then we just declare the host name of the certificate authority. So now it's listening for the authentication. And again, the -CA, this is the host name of the DNS because it's going to make that relay against the /cert srv cert fnsh.asp. So we're using the host name. So whenever we looked back at our output from the Ceritpy find command over here in this section of the CA, we're looking at the DNS name, not the CA name. This is the name of the certificate authority. This is the name of the machine itself. So it's very important to distinguish that. You will get issues if you're trying to relay against this. DNS name, that's also not the name of the DNS server. I got it confused whenever I first started messing with this. I thought this was DNS server. This is the domain host name of that machine. So we have that set listening, and now we can use that DFSCoerce that I mentioned in the manual method, and I'll link below, which is this right here. And we just need to pass credentials, so you do need valid credentials to do this. We're gonna do the IP address of our attacker machine, followed by the machine that we want to coerce or trick into authenticating, which in this case is going to be a domain controller of the name is Mount Doom. Press enter, and we'll see that it's successfully bound. You might get some error after this, such as bad network path, but that's totally fine because with DFSCoerce, what it's doing is it's tricking the machine to authenticate against our attacker machine. So it creates like a fake share, and then it tries to coerce the target machine to authenticate, so that's why you get some errors like this, but that's totally fine. If we look back at our Ceritpy relay command, we'll see that it did declare that it saved a certificate in the private key into the file of mountdoom.pfx. So now if we list our files, we see mountdoom.pfx, and now we can obtain NTLM hash of that machine account the same way we did earlier in the manual with the get nt hash command or tool. This time we'll be using certipy auth. We're going to pass the .pfx flag and then the name of that .pfx file. And then again, I like to declare the DCIP since it'll be need to do some authentication against the machine. So I just like to declare it as well. And right here, we can see that it got the hash for the machine account, and then it prints out the NTLM hash. So what I like to do right here is similar from before. I'll just grab a NTLM hash of any user in the account that I would like. So we'll be using a secrets dump, similar to the manual way. We declare the user that we're going to be using to authenticate as. So domain / Mount Doom or your machine account name, make sure to add the $, and then the machine account the machine that we're going to be authenticating against, which in this case is also the same one because it's the domain controller. Put the hashes flag there and then provide that hash that it outputted earlier. And then debug just in case there's any issues. And again, and I'll explain it again. So just DC user is just to get one user's NTLM hash in a real environment. There can be thousands of users, so you don't want to dump all the users' hash because it'll put it in an ntdit file that's saved on the domain controller. So for security reasons, you don't want that file on there. You just want to grab just one NTLM hash of one user. You could get 2 or 3 as backups just in case. And again, this is a domain admin in the environment. And then provide the DCIP address as well, just to reduce errors. You might not need that, but I like to use it because in real environments, sometimes you get some weird issues, so I just declare it as well. And then it uses the DRSU API method, and it grabs the Gandalf user's NTLM hash. And right over here, we can see that it grabs that NTLM hash. So we're going to use crackmap_exec to pass the hash. You could use whatever pass the hash tool that you like, but I just like to show that it is a valid set of credentials. So I'm going to use crackmap_exec using the SMB protocol. The machine I'm going to target is going to be the domain controller IP address. I believe you could also put the host name as well. The user that you're going to be authenticating as, -H and then a colon followed by the hash and whatever command you like. I just like the shares command. Press enter. It does show pwned because we do have administrative access on this machine, which is the domain controller. The way that crackmap_exec shows that it's pwned, or the way that it determines that it's pwned and that it has administrative access, is because we have read and write on the admin share. So whenever you have read and write on the admin share, that means you have administrative access on that machine. So showing that you have administrative access on the domain controller shows that you pwn or own the domain. So now we could go into the remediation and look at our certificate authority and show that the quickest remediation is by disabling NTLM authentication. You can also enforce HTTPS, so it doesn't have that HTTP endpoint, just HTTPS. But as long as you disable NTLM authentication, then that's good enough. But we also like to encourage to also enforce HTTPS because that's just in general good practice. So let's go into the certificate authority and take a look at the recommendations. So first, I kind of want to show you what the templates look like on the CA itself. So if we go to tools and then certificate authority, and then right here it has our domain and certificate templates. So these are the published certificates. So whenever you're looking at the output of Ceritpy, and I'll also mention this in my other video for ESC1, sometimes the templates show that they're vulnerable, but they're not actually enabled. So say enabled false. So if they're enabled true, that means they're right here and they're published. And right here, find me 1A and 1B are the ones that are vulnerable to ESC1. That again, I'll go into the video on ESC1. But if we look at manage, these are the templates that are not enabled. So these will show up on the output, but they're not enabled, so you can't exploit them. But for this video, I'm not going to go any further in that. All right, to show you how to remove NTLM authentication at the IIS level, we'll go to Tools and then IIS Manager. Follow the drop down over here, Sites, Default Websites, Cert SRV. We're going to look at the authentication, and right here under Windows Authentication, we're going to go to Providers. The NTLM authentication we're going to remove since we don't want that, and then the Negotiate. We're going to click Negotiate Kerberos. Make sure to add click the Add button. If not, then it won't be added. Sometimes I'll just go like this and I'll forget to click Add. So remove that one as well. Click OK, and then reboot the server as well. So now that we have that remediated, let's go back into trying to perform the command just to see what it will look like from an attacker's perspective. So we'll run that same curl command just to see how it looks now. We'll see that it does have negotiate, but we did change that to negotiate Kerberos, so I think it just doesn't pick that up. But we don't see that NTLM authentication. Now, an important thing to remember is to make sure to have that setting of negotiate Kerberos, not just negotiate, because I believe it's still possible to exploit it if it's set to negotiate and you didn't remove that negotiate option. So only have negotiate Kerberos. And if we go into the relay, we'll set up the same relay command. We'll do the same DFSCoerce attack, and you'll see that it doesn't output anything. We could try it again. And it's still not able to relay against it. Now let me remove all of these files to show you the new output. So if we run that same Ceritpy find command, we'll see that it still declares that it is vulnerable. So if we look at that file again, and I'm just gonna get the top maybe 50 lines just so we can just skip right to the parts and I don't have to go on the way bottom. I'll just get the top 50. We can see that it still has that certificate authority declared as being ESC8 vulnerable, because like I mentioned, it just performs a curl command, or maybe not necessarily a curl command, but it just tries to make a connection to the HTTP endpoint in general with a /CRSV, and if the site is live, then it declares it as enabled and it'll mark it as ESC8. Now, it's not to say that Ceritpy is a bad tool. I love Ceritpy. It saves so much time, but just to let you know that there are some improvements to be made, and not to fully trust a tool, and that's just tools in general. You can never fully trust an automated tool. There are fallbacks to automating certain things. So this is just something that I came across in my real pen test. So I like to do the curl-i command to check it out as well. So that covers NTLM relaying against ADCS or CA Web Enrollment HTTP endpoint. Again, I'll make a video right after this going into the ESC1 vulnerabilities and talking a little bit more about templates and how those can be exploited for privilege escalation. That one will just be automated because there's not really an easy manual way to do that. But it's a really interesting video. ESC8 and ESC1 are very common in environments. ESC8 is the most common I've seen, and maybe about 80 or 90% of my pen test that I've become aware of this attack, which was maybe about a year ago or so. I'll link in the description some of the tools and the blogs that I've mentioned as well. So thanks for watching.